The next topic is the next property is basic. The next property of charge is quantization of charge. Quantization of charge means any charge body can have charge which is an integral multiple of elementary charge, that is electron. Electron is called elementary charge. So if there are two body A and this is body B, and if the charge is transferred, so we can transfer either one electron, or we can transfer two electron, or we can transfer three electron or an electron. But we cannot transfer if there are two bodies. This is A body and this is B body, and if we want to transfer 1.2 electron, it is not possible. Either one electron, two, or integral multiple of electron can be transferred from one body to another body. You cannot transfer 1.2 electron, 1.4 electron like this. So this is the quantization. That means charge can be transferred in the form of quantization. That means either 1e, 2e, 3e, or we can say plus minus ne. So this is the quantization of the charge. Now the next is invariance. Invariance property of the charge is, again, it is a very important property, and according to this property, charge on a body is independent of the speed of the body, unlike mass. Mass is also a characteristic of a body, but mass can be changed. If the mass of a rest body is different from the mass of the body which are moving, and the mass of any body is given by mass of a body in rest. The mass of the body is given by mass of the body in rest divided by under root 1 minus v square upon c square, where v is the speed or velocity of the body at a particular time. So you can see here the mass of the body as the velocity is increasing, and if it become v is equal to c, where c is basically it is the speed of the light. So when v is equal to c, the denominator of this expression become 1 minus 1, that is equal to 0, and in this case the mass of the body is infinite. So as the speed of the body is increasing, mass start changing, and when the speed of the body is equal to the speed of the light, then mass of the body become infinite. So mass depend upon the speed of the object, but charge on the other hand does not depend upon the speed of the body. Say for example, this is body A, whose charge is say for example 4 coulomb, and and body is in rest position. So if body is moving, the body A, and again it is moving with some velocity v, then again the charge remains same. It will not be affected by the speed of the object. So this property is called invariance of charges. That means charge on a body is independent of the speed of the body. So this is again a very important property. And now the next is, yes, the comparison of electric charge and mass. There are similarities and there are dissimilarities. So what are the similarities? Similarities, both charge as well as mass both follow the inverse square law. Inverse square law is basically because the electrostatic force is inversely proportional to distance, square of the distance between the two objects, and in the same way force of attraction between two bodies is also inversely proportional to the square of the distance. This is called the inverse square law. So both This is the similarities. The first similarity is both follow the inverse square law, and the second is both the quantities are scalar quantities, they are not vector. That means to represent these quantity we don't need to specify the direction. It has only magnitude, there is no direction, so both are scalar quantity. And now the dissimilarities. The first dissimilarity, electric charge may be positive or negative, as we have already seen in the previous lecture that there are two kind of charges. So charge can be of two kind, but mass is always positive, and charge is strictly conserved. As you can see, conservation of electric charge, but mass is not conserved because E is equal to mc square. So whenever mass, some of the mass is converted into the energy, so mass cannot be conserved. Magnitude of charge is independent of the velocity. In the last property we have already seen this property, we have discussed this property. Charge is quantized but mass is not quantized. That means charge is the integral multiple of electron. It can be transferred, but mass can be 1.2 kg and can be 4 kg or anything, so it is not quantized. And the last is the force between charge can be attractive and repulsive, but force between mass is always attractive. So these are the comparison of electric charge and mass. So the next is Coulomb's law. We will discuss this one.